Alright, what's up guys? So we're back again with another entry in the algae series. Today, I thought about doing my first kind of clickbait title. I was going to add TDD to the title because today we're going to be doing TDD, but not the good kind. So the good kind I'm referring to is test-driven development. Where you write a test for some kind of functionality, you implement the functionality, and then you run your tests on it, that kind of thing. But what we're gonna keep doing today is to-do driven development, which you can see also can be abbreviated as TDD. So you can see even just here in this file, we've got some to-dos littered in here. I guess we can actually grep for all of them. We've got quite a few throughout the code base that we need to try to fill in. So to locate the most important ones, we can just we kind of did this at the end of the last stream, but we can try to run algae. So the, the test that we're going for is still just accepting the single digit 2, and you'll see we get a panic not yet implemented at source value rs line 32. So that's this parse right here. So let's pull up the Go version as well and start going through it. So again, we have this little outline of our parse function, but we need to actually fill everything in. So it looks like a lot of work's being done right here in parse 2. Again, we're getting this error thing, which probably means we're supposed to return a result. Oh, it looks like I actually already did that. Value. Okay, parse 2. So we're supposed to call parse 2 with conf and s, and that will return something that we don't know yet. Let's go ahead and look at that. Let's try to figure out what this is doing. Parse 2. So it said, yeah, is it complex or rational? So, yeah. Okay, we've got some initialization. So we're going to check if S contains J, which, if you remember from the IV demo, is how we denote a complex number. So that's the complex part, is after the J. So sep is J, type is complex. Else, if it contains a slash, it's going to be irrational, of course. And otherwise, it looks like it's not even a number, maybe. Okay. Okay, so if it is one of those, we're going to come down here. We're going to split the elements by the separator. If the length, if we don't have 2, so if you have like 1/2/3, we complain, it's not really a number. Oh, again, I forgot to add this to all the tags. And then I forgot the tag. Okay, there we go. Okay. Oh, we're recursing. We're going to try to parse the first one, parse the second one. Great. Error F. This is probably just, yeah, this is just a panic. Alright. Let's see what we can do here. So this is a string vector. We don't really need to do this. Yeah, so it looks like sep and type actually get set right here. So we'll do it like this. Sep type equal. If s dot contains j, then we give j and complex. Depending on where this type string is used, it may be worth making an enum for it, but we'll see. J or j complex, else if s dot contains slash, then we'll return slash and rational else we actually return from the function with two values. Yeah, so this, we're not going to want to return an error. Oh. We will return a result. Okay, the string is the separator. Okay, so it looks like we're going to return a result, which is a tuple of two expressions. These are expressions, right? No, maybe these are values. I'm just a bit confused because parse is returning an expression, supposedly, when I think it's probably going to return a value. We'll see about that. So I think these are actually values because we see these ints. We have ints. Let's go ahead and call these values. Value. I guess it's going to be a static string or a parse error. Excellent. Okay, so we return. Oh, but they say the error is nil. Error not equal nil. Okay, that'll come up later. All right, so for now we are going to return okay. Int 0, value int 0, value int 0, and the separator, there's no separator. Okay, that should be okay. Oh, yeah, I forgot some parentheses. Can delete that as well. Now, if we didn't return there, that doesn't really make sense to me, so we're just returning two zeros. If we somehow call parse2, we return nil. Not sure. Not sure. Anyway, so now we can just let elms equal. See, I'm not sure why. This might be some. Well, I see why they did it for sep and type, of course. I'm not sure why elms is up here. But anyway, s.split at sep. And if length, elms.length, I think, is this an iterator? We might just have to collect it. elms.length not equal to, or elm0 is this, or elms1 is this. Okay, I guess that makes sense. elms1 then we'll just panic. Bad. Whoops. Type number syntax. Yes. Great. Otherwise, we're going to try to call parse again. Okay. Oh boy. So parse definitely needs to actually return a value. Because then we can do let v1 equal parse. conf elms 0. Great. Let v2 equal parse conf elms 1. And then, is that a colon? What happened? Oh, I forgot the the parenthesis. Okay, v1, v2. And if both of those succeed, we can return okay. v1, v2. Oh, it has to be a tuple again. v1, v2. And sep. All right, so there's parse 2. So back to parse. Okay, if error is not nil, so we can actually do this again. And we can say let v1, v2 sep equal parse 2 question mark. We took care of the error not equal nil. Now we're going to match the separator. Yeah, okay, it's just going to tell me that I haven't handled everything, which is true. J. Then we return new. Okay, let's see where this is defined. This is probably, what is this? Returns a complex. Okay. Yeah, this is going to be, we're going to have to wrap this in OK. Complex. 2. Let's see if the LSP will help me out. Well, no, because I don't have complex. I guess these should be I32s. Okay, sure. To do return value complex. Okay. Well, I'll leave that for now. Okay, J. Slash irrational. It's tricky. I think we're going to ignore some of this type stuff. Yeah, we're going to try to ignore this type stuff for now and just assume everything is an integer. Or everything's an I32. So we won't have all of the big data types that IV has. That's okay. So we will just say rational. We're just going to return OK value rational v1, v2. Otherwise, do nothing. We need to make the rational. General mix them up. That's what I like to see. What's the problem here? Argument says variant are incorrect. Oh, these are values. Oh. Can I do that? I don't think you can do that. Yeah. Maybe parse 2 can just return integers. I don't see anything wrong with that. I see. So basically we're going to do a conversion one way or the other. V1, V2, cast it as an int. Okay, maybe it makes more sense. I'm just trying to decide which way it makes more sense. Does it make more sense to return these as values and then do .0 here to extract the actual integer? Or does it make more sense to return these as Rust integers and then pack them like this? And I kind of think it makes more sense to do all of the packing in parse. So I think we're just going to return some I32s like this. Oh, but now I see. Now it's harder to call parse. So let's, all right, we will leave it like this then. So we'll just unpack it here. .0. .0. Uh-oh. Ooh. Oh, but we only know. I see. I see. Can a complex, they are supposed to be values actually? Okay. These have to be values. Now it's going to have infinite size, right? Yep, great. I guess rationals are supposed to be a big rat. Okay, that's a little different. Great, now we have infinite size again. Alright, well, they're going to have to be boxes, I guess. And now we're going to have to impl value. These are going to be box values too, I think. So we'll have a complex. That takes, yeah, ij. And returns a self. So this is going to give us a complex of box new j. What's wrong? Oh. Wait. I guess these are supposed to be values. Yeah, these should be value. And probably want something similar for rational. Where's that macro we wrote? So this time it's not binary holders, it's I don't know what to call it this time. We'll just call it constructors. And this is very, very similar. Except we have to change the inside of this. Oh boy, maybe now we need a macro that makes these macros. Yeah, self var name, except this time it's like this. This time it's box new I box new j, and this is I value j value. This is one thing Rust Analyzer or Rust format doesn't actually format macros for you. So fortunately Emacs helps out with that. So I can delete this now, and we can say constructors. If we spell it correctly, we'll call it complex. Got it backwards, rational. Great. So now we can come back down here and just make these lowercase. Perfect. Okay, so if we match one of those, we do that. Otherwise, do nothing. Okay. Now we'll come down here. Can I put comments in here? Complex. Rational. Note. Skipping tricky case of big rationals of big numbers. Okay. Not irrational, but might be something like 1.3 e minus 2, which could become irrational. All right. Let I equal set int string of const s question mark, because we see this error nil stuff again. We'll try that. Let big int string. Big rat from float string. Alright, let's see what we got here. Set big int string. Whoops. Let be s. We might be able to skip this one. We'll see. Let R be set big rat from float string s. Oh wait, I have this backwards. Hold on. This is the opposite of question mark. If let sum I equals this, then we return I. Okay, I. This should be okay actually. Hold on. Maybe we actually want if I dot is okay, return I. If B dot is okay, return B. If R dot is okay, return R. And then if we make it all the way down here, we'll just return error, parse error. This feels kind of dumb, right? Why does it look like this? All right, let's start generating stuff. Set int string. Oh. What is int bits? Whoa, 32. Okay, that's fine. So all we're going to do here is we just return i32.parse from stir s, where our base is conf.input base. Okay, this might not be the right type. Switch to u32 as u32. Okay, so this is a real parse error. Okay, that was easy enough. 32. Okay, great. Okay, so we're going to be converting the error type, so we can actually say if let sum I, okay I, is this, then we'll return our okay of I. Okay of int I. Value int I. Great. Value int I. Okay, let's go back and look for set big int string. I think we're just not even going to do that. Yeah, we're skipping big ints. Note, skipping big ints again. Okay, so the last thing to try is this. The input is known to be in floating point syntax. If there's a slash, the parsing is done in parse. Okay. Alright, so we can generate this one. If not, s.contains if the given pattern matches a subslice. Let's leave the documentation for this. If it's pattern can be this, a slice of charts. Can I just put this? I mean, yeah, it would be nice. Contains. I'm gonna have to leave the docs for this. Okay, it looks like we can just give it, if we give it this slice, I think it'll do the right thing. Ooh. Rust playground. (1.3e minus 6). 1.3e 1.2 dot contains. We're looking for, well, let's try the Go version first. .ee. We better actually print this. Run. False. Okay. Now let's try this. This is basically what I'm hoping will work. Probably we have to borrow it. Whoops. Let's try that. True. Okay. Let's roll E12. True. And capital E. Okay, so if we use a character slice, it should be fine. We got dot, we got E, we got E. Panic, bad number syntax. Otherwise, let E okay, E false. Big dot new rat set string. What is this? New rat. So we try 0, 1. Wow. Wow. I don't even really care to support rationals, honestly. Whoops. Yeah, okay. I think for now, let's skip the rationals. Okay. Let's... or should we just use this library? Collection of numeric types and traits for rest. Wow. Okay. Non-rational. Let's use this one maybe. Oh, I see. A metacrate. All right, we'll use it. Deprecated. Oh, okay. Yeah, we'll do rational 32, I guess. Okay. Ratio. New. All right, let's do num rational 32 new. Oh, can we parse from stir? All right, s can be given as a possibly signed fraction or as a floating point number. All right, let's see what we can do here. From stir. S. I mean, let's just see if it works. And then we can add this function's return type. Okay. I mean, let's write a little test here, right? Big rat. Oh, I forgot no capture. Oh boy. Well, that's not good. Okay. Yeah, take this off. And we'll mirror the thing over here. If let okay r, and I'll return ooh, it's supposed to return two values. Okay, we might have to. Okay, we're gonna have to unpack this a little bit. Let r. Whoops. Completely got that backwards. Let r be this. So here we know that r is okay. So we can return a value rational r dot number okay. So this is going to be now a result of value there. Okay, of r. No, it already is a value. Okay. Whoops. What's wrong? Oops, there. What's the problem here? Oh, value int. What does this return? Can I do that? Hopefully. Alright, let's see what Clippy is mad about. Match arms have incompatible types. This is found to be... Oh, this is why we made it return an expression, I think. That's a little tough. Because parse... What is an expression? This says it returns an expression. So this is where we might run into trouble. Expert. Which Go code are you asking about right now? Because it might be longer because it's just not implemented so far. Or do you mean the Rust code? I think we actually do have more Rust code than the Go code right now. And that's a good question. I'm not sure if that's what you meant. Well, I have, if that is what you meant, I have an idea. Let's see, value. We have to figure out what to do here. Because this returns an expression, which is an interface. But this is a very small interface. It just has these two. Whereas if we go look at parse, parse returns a value, which is another interface that is like a super... I guess I always get these mixed up. I think expert is like a subtype of value. Oh, okay. Okay, no, then yeah, that's just because we haven't implemented everything yet. Yeah, if I go back to parse.go number, I see, yeah. So here we're at 580, but over here we're at about 380. I think I probably have a bunch of to-dos. Let's search backwards for to-do. That one's actually below where we are. But I'm sure we've skipped some stuff. Index list, index, operand. Maybe not, actually. Well, if it's genuinely shorter, then it's probably because of all of this stuff. So you can see when they do like error checks, right? They do stuff like this. If expert not equal nil. And I've been trying to actually use the question mark operator, for example. So maybe it's all added up. And I've even been copying the comments over, so it's not just that I left out all the comments. Neat. I mean, that's kind of what I'm hoping for, is that it will be shorter in Rust. But we do want it to be shorter for the right reasons. So some of the stuff, I've been skipping some stuff today. Like, I'm not really that interested in rationals, although I think we went back and actually added support for rationals after I said that. I'm genuinely skipping the big num or big int stuff. I'm happy with small integers for now. Yeah, but it looks like we're just, our code's just a little shorter so far. We do have to figure out how to handle this. Well, the reason we went to these enums in the first place is that we're keeping around collections of, certainly of expressions. They can be of different types. And so if we go back to a trait, then we're going to have to use trait objects everywhere, which is why I preferred the enum. And for value, I think value is now an enum as well. It does make sense for values and enums to be the same thing, though, doesn't it? Or values and expressions. Because expressions should be evaluated to values. So a temporary thing I'm considering is if we run Clippy, we just see that these match arms have incompatible types. So we could write. So I think this is supposed to return an expression, but we're giving it a value from parse. So something we could do is just make it easy to convert between the two, right? We could impl from value for expr somehow, and we can just call parse, v dot. We'll just call like v dot into. I think. But that's a little annoying. And we're going to be returning... Let's see if it even makes sense to do that conversion, right? Like, we've got one of these values. Now, what kind of expression would we turn it into? We don't have anything like a literal, right? I mean, we could add one. Yeah, I guess we could just add one. Value. Maybe that's the way to go. We have some kind of... I mean, that makes sense actually, right? It's just a literal expression. Or a constant, or a value, I guess, whatever you want to call it. Slice expression, unary expression, indexing expression, a variable expression, binary expression, conditional expression. Yeah, I mean, I guess we have a character here. Where do we use this? We don't use it? Do we use it anywhere? Ah, we use it here. Vec. Eval string gives us a vec of expressions. And where do we use this? But the issue before, I think, was what I had really messed up with the lifetimes. So it may be possible to put these back as traits and see if we can more closely mirror the Go version. Yeah, we might be able to do that. And then this time we'll definitely use box din expr everywhere instead of... Before I was trying to do ref din expr, which then complicates things with lifetimes, because when you look at their expressions in the Go version, let's see what actually implements expr. I think there's like expr struct or something. Oh boy. Yeah, I just can't remember. Also implemented by value. Yeah, but in short, maybe we can do this now that we got rid of the crazy lifetime stuff. So this would return on impl expr. All right, let's look into that. Let's go ahead. I'm going to commit this. Work on parser. Work on parsing numbers. And I think, let's see what we can do here. I think we really simplified our context, right? It holds a config still, but the config's not generic anymore. Feels kind of bad throwing this stuff away, right? Yeah, all right. Maybe we don't throw it away. Maybe we'll just do what I mentioned. It doesn't sound that bad. Let's go up to our expr, and we'll just add this. So it's value. Okay, and then we'll do impl from value for expr. So we've got a value. We're just going to return a self value containing that value. So at least now we have easy conversions. So if we run this now, when we do this, we'll just say v.enter. Okay. So yeah, this isn't used. Sure. The borrowed expression. Oh, excellent. This result must be used. Oh, and I wanted to try the test. Does it work? Oh, I didn't do capture. Okay, great. So we got a parse error. Parse ratio error, kind parse error. Yeah, that's what I was afraid of. Okay. From integer to integer. We want from, oh, we can do from float, actually. All right, we're gonna have to go back to this. Set big rat from float string. Big rat from float string. Okay. If not, okay. The input is known to be in floating point syntax. Okay. So I guess we need to actually call we need to try parsing it from the string first. So we're going to say let f be f64. Well, we can just do parse s.parse let's see if we can just do like impl error, maybe. Why does it matter? Consider specifying. But I don't know the type of the error. This is something I always forget or just don't know how to do. Question mark with multiple error types. Do I just have to box it? I don't want to use. I know I can have my own error. I don't want to define an error type. Yeah, can I just box it? I thought impl error would work. Anyhow, yeah, I've heard of anyhow. This just feels like something I should be able to do without a crate. Does this work? Okay, this is fine. This is fine. I should actually look at anyhow though, because I've never used it. Thank you, yeah, boxed in. Anyhow, error. Yeah, this would be nice. Anyhow, result T. It's pretty cool. I should use this at some point. All right, but yeah, we'll stick with this for now. Yeah, Actually, working on this has shown me that I think I'm a pretty novice Rust user. Because a lot of my scientific code, the stuff I write, it like needs to work or I can just unwrap. So I haven't done a good job of handling errors really anywhere. I haven't used the question mark very much, and yeah, stuff like that. So this isn't used. We need to actually try from F64 on F. And if that all succeeds, okay. So this is an option. Is there like a try from? Yeah, maybe we can try from F. Ooh, no, that really didn't work. Is there a way to convert this into... Yeah. Unwrap or... Oh. Does this... Converting... No, I want to go the other way. Okay, yeah, do I need unwrap or... Oh. I don't know. Yeah, alright, let's try unwrap or. Unwrap or... Okay or... Ah, thank you very much. And then we will use our error here. Oh, thank you very much. Okay or... Oh, can I not do this still? Oh, we can't use ours. Error. Oops. I need to box it again. Thank you for the help, by the way. Struct. Oh, do I just need to represents? Okay, this we've got an error type. Do I just need display? Maybe we can just return a, what did it return before? Parse ratio error. Oh, whoops. Parse ratio error. We need to actually create one. Parse ratio error. Maybe we can use a standard error type. This is quite embarrassing. Okay, or. That was really handy. I appreciate that. Transforms the option into a result. That's good. Okay, or. Now we just need some kind of error value. I think, shouldn't there be some kind of parse? Standard string parse error. From bad value. Okay, why does my thing... Okay, I need to get rid of this. Oh, goodness. Okay, so we need to satisfy this. Let me go to parse error. What else does it need to be? Does that do it? Required for box. Okay, do I just need to box it? Like you said? I don't think so. But it seems that I can't. Alright, what am I missing here? Struct double error. I implemented display. I have debug and clone. Does this not work? Boxing errors. Oh, is this what I need? Oh my goodness. Okay, great. And now we do get this. That looks good. 2,500. Perfect. Okay, it looks like we actually got it now. Rational 32. Oh boy. From stir 3 over 2,500. Set big rat. Okay, we have to use the trait. And I need to unwrap that for the test. Oh, right. So this is supposed to give us back a value rational 3,2,500. Let's try that. These are supposed to be values. Value int. Great. Okay, so we did do a little bit of real TDD, not just to-do driven development. Okay. All right. Clippy's happy. Everyone's happy. We've got rationals. Let's look back at parse. Well, let's go ahead. Let's check. Can we run anything now? 2. Ooh. From stir. All right. Probably this should be handled in input base itself. But if base is 0, base equals 10. And then we'll actually use base here. There. That's actually kind of exciting. Okay. Where is this? 100. Eval! Okay, we made it to eval. That's fantastic. Now we have a slight question. Should we keep going with our to-dos in here? I really want to be able to evaluate something. Did we finish everything? We finished parse. We finished this. We have this test here, which we probably shouldn't have. Set int string. So we're gonna be responsible and try to fill in some stuff here. Let's try to write parse string. Parse. Whoops, we gotta go back. Parse string. It's supposed to be value.go. Parse. Wait, where is parse string? Where is this called? It gets called in parse. Back to parse. We're looking for number. Parse string is here. Okay. So let's work on this. So we're supposed to say let s equal unquote text, else panic invalid string syntax, invalid code points in string. So the fact that ours is already a string means that that is the case. This is actually supposed to return a result. And we don't care about that. I guess this is actually going to be, we're just going to return unquote text dot unwrap or else. Great. Now we just need to do unquote. Just need to do unquote. It might be a very long thing. Unquote is a simplified strconv unquote that treats this and this equally. Raw quotes are go-like. The return value is a string. Okay. So this will be a result of some type. We don't know yet. All right. Let n equal text.length. We'll change this name to s. If n less than or equal to 2, return, in this case, OK would be false, because that's the default for Booleans. So this is, we'll return an error. Error, I guess we'll use our parse error again. So this is either a string. For now, it's going to be a result string. Parse error, but we'll see about that. Okay, otherwise, let quote be s of 0. Try that. If quote not equal chars of n minus 1, return error parse error. Let otherwise we'll take chars be chars from 1 to n minus 1. So we're just cutting off the quotes. That's fine. If quote equals this, if s dot contains a back quote, return error, parse error. So I guess basically we are checking right now if our quote contains the wrong number of quote characters, right? So what we did right here is we're just extracting the quotes from the ends. We're assuming that they're the first and last character. And now we're looking inside of the string. This should be chars, I think. So if our quote was a backtick and our remaining string contains a backtick, that's an error. Otherwise, we can return OK of string from chars. Hopefully. Can we do that? I don't think that's the issue here. Otherwise, if quote not equal double quote and quote not equal single quote, return error, parse error. So we have some type issues up above. So basically there are three types of quotes: single quote, double quote, back quote. If it's not one of those, then it's a disaster. Now we'll check. Ooh, do we need to actually look at this contains? Oh, because it's looking for bytes. That's okay. We're just going to look at characters and hope it's okay. So now, if s dot contains a new line, let's put a note in here. Note, Go version looks at bytes, not chars. We need to use UA. Okay, well, we're going to hope to avoid that. So, if s contains a new line, parse error. That makes sense because only the back quoted version is allowed to contain new lines. So we would have already handled it up here. If not, s dot contains a backslash and not s dot contains s quote, whoops, then we can just return it. Well, we can't. And there's something wrong still, but anyway. Let's try to figure this out. So this is supposed to return, okay, a buff. Well, let's just return this for now. Okay, so that should fix the return stuff. Chars dot contains. What is this supposed to be? Oh. Alright, that's easy. Is this the same? No. This might be a real issue. We might have to do like try from. Yeah. String from. We do try from. Do we have to collect into a string? Can I use into? That's a good question. Try into. I think I was using just the other side of into a second ago with the string from. Let's see if we can do try into. That's what I thought you could try into. Ah, okay. Maybe that worked. No. Unwrap or else. Chars. Oh, right, because I have the, yeah, that's good call, good call. If that part works. Probably we should, okay, fix that. It just seems like I can't convert from a slice of char. You can convert from a single char. Okay, might be back to Google situation. Oh, you do just collect it. Okay. I was wondering about that. So we'll do chars into iter.collect. Okay. That works, I guess. Yep, good call. You were right. Fortunately, Clippy told me that too. But yeah, we can just use iter. Great suggestion. I just took this one. That's what happens when you copy and paste straight from Stack Overflow. If you need to keep it. Okay, cool. So we're a little closer there on unquote, but we need to do this part down here. Unquote char. I don't know what this stuff does. What do we do with this temp? Rune temp. Wow. That's quite large. Oh. I thought this was going to be the maximum code point, but apparently, I guess it's like the maximum number of, I'm probably getting my UTF-8 terminology wrong, but the maximum number of code points in a character. Number is fundamental to the encoding. Okay. Yeah. Okay, yeah, good question, Matthew. What sort of comp chem do you do? So, I need to practice answering this question since I'm going to be looking for jobs next year. But I guess my group does vibrational spectroscopy. So we do usually like, let's see. I mean, it kind of depends also who's asking. I don't know if you're a chemist yourself or anything like that. But I guess assuming not, we try to compute what the spectra of molecules looks like using some pretty expensive methods. Yeah, frequency analysis, pretty much. Yep. Yeah, so, okay, it sounds like you're pretty knowledgeable. So I typically use explicitly correlated coupled cluster theory to calculate vibrational and rotational spectra of relatively small molecules. We usually use what are called quartic force fields for that. So we're not just doing the harmonic frequencies, we're calculating a local potential energy surface from which we can extract the cubic and the quartic force constants, so we can get anharmonic values, or we can get anharmonic values for the vibrational frequencies and the rotational constants. I really need to do a video on my research, but I haven't put one together yet. Yeah, we usually use MolPro for the single point energy calculations. Yeah, I do a lot of programming, kind of trying to automate the generation of the potential energy surfaces. But for the actual quantum calculations we're doing, or computations, we're using just normal software. Hey, thank you. Yeah, thanks for stopping by. No worries. I think you can watch the recordings later if you do like them. But thanks very much for the kind words. Yeah, but I was saying, I think, yeah, I write code, basically the interfaces with a standard computational chemistry package. And the main one we use for our coupled cluster stuff is MolPro. Sometimes we use Gaussian. And the stuff I'm working on for my, kind of like the unique portion of my dissertation, I'm also using some semi-empirical methods, so much, much cheaper. We're doing some cool stuff with that. And for that I use Mopac. Yeah. So always using some of the standard codes. I have played around a little bit with writing my own stuff, but not like production stuff, just for fun or for my understanding. I think I got these backwards again. I have not heard of that podcast. What is that? 3 times length s over 2. I kind of think that we don't need to do this. Because we are iterating over the chars. I'm just going to put, yeah. I think here, oh no, oh, that's what it means by unquote. I see, I see. Unquote. It means like with a backslash. Escape string or character literal. Oh, nice. Yeah, I do. I listen to podcasts usually like when I'm working out or driving. Fortunately, I've been working from home, so I haven't been doing much driving. But I'll have to check that out. I'll write that down. That's awesome. Thank you. Yeah, I think I'm an aspiring APL lover. I talked about this maybe on the first stream or sprinkled throughout the many hours of these, but I've tried playing with APL a bit before, and never. I think it's really cool, but I've never really been able to use it productively for anything. So I'm hoping to actually put algae to use. And if I can't get algae to work, then I'll try using ivy. But for now, let's see. I think we're just going to do UTF-8 stuff. We're just going to hope that this is a simple string, basically. Yeah. Oh, right. I haven't actually done anything yet, right? 2. Okay. So that was unquote. Parse string, unquote. Okay, I think that is done. We might be done with value. Let's go look. Value.go. Value. We might be done with value for now. Parse to parse okay. Yeah, we might be done with big int 64. So these are just like variants, I think. Big int. Yeah, let's just, for morale's sake, let's go to our README. We'll say we're done with value.go. We're at least mostly done. And now, if I try to run it again, we're panicking in expr. So let's go back to expr. And we need to implement eval. This is exciting. This is ooh. Okay, right. They don't have expr. So we're looking, whoops. We are looking for eval. Just plain eval. So it's a, that doesn't look right. eval, for some reason I have it taking a context. Maybe we need to find the expert interface. Oh, here we go. So this is what we're looking for. We are looking for, I keep typing that. This is actually, I mean, this is totally unrelated, but that is actually an issue I ran into when I was learning to use Emacs, is that there are so many key bindings that are so powerful that I just felt like totally out of control. So what I keep doing is I hit Control-C-V, which I have bound to spawn a terminal in the same directory as the current file. When I'm trying to hit Control-C-G, which I have bound to console ripgrep. So we're looking for func eval context. We are looking for all of the evals. Wow. Okay. Unary. I think we're actually looking for a value. Eval context value. Well, I guess the first thing we can do is debug self. Okay, target run, 2. So self is a value. So basically what this is gonna come down to, we're gonna match on self. These are all the different things we have. Let's allow dead code in here. And we're only looking at this simple case right now. So we need to figure out how to evaluate a value. So I guess we go back to value, eval, and I guess now we start looking at the data types, right? So I have integers. Great. What is eval? How do we eval a value? Well, I guess it just returns. Why is this? Let's go back to run. Interactive, print values. Values equal context eval. Sure, I guess this just returns some beat. Easy enough. What? Return. Value. Can these all be cloned? Let's go see what values are. I think these. Oh, maybe we can't. Can these be copied? No. Okay. Well, we'll probably just clone it then. Okay. How about now? 2. Ooh. Oh no. Oh God. Okay. Yeah. So this means that the stuff we tried to do with our ref cells is not allowed. So if we go to run, what was it, like 37 or something? 30 maybe? Borrow. Probably it's right here. This context is already borrowed. This is just so annoying. This is so annoying. I think probably what we're going to do... Alright, let's just... Whoops. Let's take a look at the Go version for a second. Let me go back to run.go. So the issue... Actually, we need to go to ivy.go. Alright, so again, the issue, if you don't remember from the last stream, is that we have this config. Okay? And I think, for the most part, it's like a global config. But we also, when we have a context, it holds, a context holds a pointer to the config. So in our version, our context holds a reference to a config, which was one of the reasons that lifetimes propagated wildly through our program. Okay, so this holds a pointer to a config. Now, if we go down a little bit, when we create a scanner, this scanner holds a pointer to... Oh, it actually... Oh, apparently it holds a copy of the context. Okay, that's good, actually. That means I think that we can give it its own context. Is that right? That doesn't make any sense. And then this parser also takes a context. The context must have been created by this package's new context function. Oh, no. I see. Context is an interface. No, I think it does hold a pointer. So it casts context as a pointer to a context. Does the scanner do the same? I missed it. This looks like it actually copies it. And then we also hand this off to run, right? It also has to take a context. And I think all of those contexts are the same. Like, they need to know about, they need to see updates from each other. And we can't express that in Rust. Well, I mean, I'm sure that we can. I just don't know how. What I tried originally was just using normal references. But then my scanner had to hold a reference to the context. Oh, God. I don't know. Let's rerun this. Did we hit 10% at least? Alright, great. Really, I think we're beyond 10% by a little bit. Yeah, wait, are we done with run? I don't know. When we're not going like straight file by file, it's a little hard to tell which ones we're done with. Yeah, I'm not totally sure now. But we ticked off scan at least. Oops. Yeah, save it. Update progress and readme. Sorry, what I'm doing right now, I'm just trying to commit the stuff that we have done successfully. This should actually be progress on parsing, I guess. Let's do rebase. Oh, whoops. I want to combine add test recipe. Whoops. How do I move it up? I always forget how to move it. Oh, there we go. And then we're going to squash it. What? Oh, did I get it backwards? Alright, let's edit. Hold on. I messed this one up. Abort? Yes. Let's try to rebase this again. Whoops, I messed it up again. I'm trying to be better about these commits. Alright, work on parsing. Okay, so we need to squash that way. Okay. Let's just take this one. There. Oh wait, but I wanted it to be at the top. There. Okay, we reordered it. Wait, what? Oh, do I want it at the end? Progress on parsing. There. Okay. Jeez. Okay. I guess we're going to try to go back to the reference version. Man, I feel bad. We can't quit the stream already. How long has it been? Almost 2 hours. I feel like we've barely done anything. But I'm just, I'm feeling slightly devastated at the moment. Yeah, already borrowed. Trace. I also don't know why our prompt isn't being printed initially. Yeah, Rust can be like that. I can probably, we could use like an unsafe cell. I just don't know here what the right thing to do is. Maybe I just need to think about that for a little while. Probably off stream, so I'm not just sitting here silently looking at this. Let's go look at let's look at some of our data types again. Okay, so this config should be fine. And I think it feels like the config should be static, right? Like we use the config once. The issue though is that sometimes they mutate the config, I think. Yeah, that's exactly right, Matthew. Probably, yeah. Like we're doing this translation. I've been trying to go line by line, with some changes, like I was saying, with the trait versus enum thing. But yeah, like we may be at the point where the whole thing needs to be reworked. Not the whole thing, but a lot of it might need to be reworked in a rusty way. And this, I mean, I knew this was not really a rusty way of doing it. This was supposed to be a hack, basically, to get it to work. Yeah. I mean, maybe we can just... I think maybe what we can do is use a mutex, which doesn't seem like... That doesn't seem exactly right, because... I mean, it's single-threaded, right? But what we're trying to do is hand out multiple mutable references to this context, because the scanner needs to be able to modify the context, the parser needs to be able to modify the context, and while we're running it needs to be able to modify the context. Yeah. Well, let's try Googling it. Maybe people will just say to use a mutex at least. Yeah, what's the best way to have multiple mutable references? Well, first of all, don't, of course. Yeah, redesign your structure so that you don't have to implement this. Yeah. So we might need to take a closer look at the context itself and see if there's any way to get around sharing this and mutating it all over the place. So this is an execution context. If we look at scanner new, let's just look for where the context is used. This is just using the config. Context. Yes. This one might be okay as a reference. This looks like a read-only. Oh, but then, yeah, again, we can't have the scanner, we can't give the scanner a shared reference and then take an exclusive reference in the parser or in run. So I think that's actually what we had before. Like, it's fine for the scanner to have a read-only reference. It's probably, I don't think it's fine for the parser. I think the parser actually mutates the context. These aren't mutating. Yeah, immediately. Set constants. Assign global. Context. I mean, we only ever have one context, though, right? So, yeah. Basically, we just have like a global context that can be modified. So maybe a mutex is the way to go. Now we might run into an issue if we tried using this, because potential deadlock example. We might run into issues here, like are our types going to satisfy send? Oh, to be sure to, okay, no, we're not going to do that. That makes sense. Well, as another kind of hack, let's just put a mutex on our context. And we'll make everything take a mutex. Well, I think we should probably use the second thing I looked up, the reader-writer lock. Yeah, let's try this. RW lock. RW. Okay. Okay. And then we are not going to clone anymore. We'll give everybody their own oh, read. Okay, all we're doing here is read. I guess we have to unwrap it. Config. Okay. Read. Unwrap. So everywhere we have borrow, we just have read now. No method borrow. Let's try this. We'll replace borrow with read.unwrap. And I spelled unwrap wrong, of course. Yes. And then when we find, and then we'll replace borrow mute with write. Okay, so now let's replace, we can replace RC ref cell context tick A 1 2 3 with RW lock context tick A. Yep. That was easy. Let's check that. Can't find this, of course. Here we go. So now, instead of borrow mute, I think, can we say write? Whoops. Write dot unwrap. Replace borrow mute with write dot unwrap. What? Now how do we do it? now do we take a reference to the mutex? Or can we clone it? I don't think we clone it, right? I guess this has to be a reference. Okay, this tick A is tied to context. I mean, we'll try tick A, I guess. Okay. Does that work? Can I move out of context because it's borrowed? Okay. I feel myself digging a hole here. This needs to also take a... Three? Four? Uh-oh. Okay. I have no idea what's happening right now. But it didn't crash for the first time. Can we make it we can't even make it crash. I don't know what's going on. Okay, well, I guess this worked. Okay. Yeah, I don't know what's happening. So it printed the prompt once. Yeah, time for debug, that's right. I think, did I get this backwards? While is error. I think it's supposed to run, typical execution is loop until, well no, I mean the program didn't exit, so it's still in this loop. I don't know. Debug. I don't really want to dump the context, right? But exit live. Can we set something? I mean, I have like none of the operators implemented, so this just isn't going to work. Let's just debug still alive. I mean, I know it's still alive. No? Oh. Oh. I see. So something... I think we're in an infinite loop then. Okay. Let's see where we are. Yes. Oh no, is it deadlocked? Let's do cargo run. We got two. pgrep algae. Okay. Let's try strace. Oh god. Let me hide everything for a second. Blank. Can I mute myself? All right, people online made me paranoid about, you know, like typing your password and stuff. All right, we've got strace now. No. Did I change this on my laptop? I know I've used strace before. You might have to change like a kernel parameter or something. Mm-hmm. No, 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 no. Archland, what did it say? strace attach operation not permitted. I'm not using Docker. Yeah, I think this is what I have to do. All right, I'll try this. Hold on. Time to hide everything again. Okay, I think we're good to go. In one sense, and bad in another sense. Great. Let's see. So it's waiting. It's trying to read. Okay. Now it seems to be waiting forever. What is it waiting for? 2. Wait. Oh, do we have to drop this? We might really be deadlocked. Yeah. Okay. Oh, okay. I think we are actually deadlocked. Because we took the config here. Yeah. This is so stupid. Why don't we just take the config? Why don't we just pass in the config? I think it's because we're mutating the config later, right? Is that right? Config, what is this? It returns you a pointer to the config, like you're going to start messing with it. Conf. Let's just look for conf. Let's just conf equals. To me, the config should not be changed, right? But I think they do change the base sometimes. Maybe not. Okay, if the config is never altered, then we'll just pass in the config, right? And this is, of course, assuming that they call it conf. So this isn't a perfect search for sure. Conf is new config, new f on conf. I haven't seen anywhere where they alter the config. But I remember seeing it, I thought I remembered seeing somewhere where they actually changed the base in the config. Maybe not. Okay, let's go back over here. Let's just pass in the config to run. Okay, why don't you just take conf as a ref config, and then we'll get rid of this. Conf.prompt. Great. It's supposed to also take a config. Conf. Okay, that means that the context no longer needs a config in it. Is that right? Let's try this. Run. We're attached to. Still alive. Okay, we broke the deadlock. That's good. Can we do it again? Okay. 2 plus 2. All right. Now we don't know how to evaluate an expression. Okay, great. Now, does this even need to hold a config anymore is what I'm wondering. I think it might. Yeah, I think it might. So I think what was happening here is that we were taking a lock on our context just to access this config, just to access its config field. But then when we needed to lock the context here or here, well, I mean, really here because it's the next one, we couldn't because we had the lockout here. Yeah. Okay. Okay, we're still alive. Okay, let's change to RW lock from RC ref cell and break our first deadlock. Our first deadlock, probably not the last one. Where is that still alive? I think I can take out the still alive now. Okay, great. So now we need to know how to parse a binary expression. Okay, excellent. Okay, so we need to know how to eval a binary expression. Let's go look at this. Let's look for eval. Okay, apparently not. Potentially unused parameter. Interesting. Yeah, maybe we should have just contributed all of our fixing all this linting stuff to Ivy. I'm not sure they would have appreciated that. Okay, we're in binary. We are trying to call eval on binary. How do we do that? Probably we can look at, we'll look for eval binary. So again, their expr is well, it's equivalent to a trait for us, basically. It's an interface. So we need to find the type that, basically we need to find where they implement. This is why, yeah, this is so much nicer in Rust because I could search for impl expr for binary. I know they have a type that is binary, right? Or I think. Wait. So we're in eval. Oh. Actually, maybe I need to look at the stack trace. Rust backtrace. 2. 2 works. Okay, here we go. So we're in context eval. So I guess I need to go back to context eval. Oh, that's how we're going to find it. Context eval. So we loop through, we call expert eval. Okay, of course. So the type of our expression is binary. So we need to look for, maybe it's binary op? Binary op? Okay, eval binary. Binary op is the interface implemented by a simple binary operator. Okay. So I guess we're looking for something that says eval binary. Eval. Well, I think this is exactly where we were before. Alright, we're looking for eval context. What is this supposed to do? Eval context value. Whoa. Eval context value function. Alright. So we have this. That's not what we want. Eval binary. Eval. Okay, here we go. This is what we're looking for. This right here. Be binary. This is in parse.go. Great. Back to our expert. Now, binary. We can finally evaluate a binary expression. Okay. If, I guess we'll call it B, right? If b.op matches equal, then we return assignment. What does assignment return? We'll come back to that. To do. To do driven development, remember. Okay. Basically, I think we recursively call this. Alright, RHS equal b.write.eval.inner. What is inner? This must extract like the inner type, yeah. Okay. And then eval binary. Alright, write.eval. But that's, in our case, it gives us an option. Why is it an option? Should it not be an option? Maybe this is not an option. Eval self. Yeah, here we're doing a flat map. Okay, let's just make this return a value. We'll just assume we can always do that. Wow, they spelled it out. Context. Alright, there's our right-hand side, and we'll let our left-hand side be b.left.eval. Context. Okay, once we've evaluated those two, well, let me take this off. So once we've evaluated the left and the right-hand side recursively, we can call context.eval binary LHS b.op RHS. And that's what we return, I think. Okay. Cargo run. Oh. Jump the gun a little there. Okay. No. Can't move out of this. Oh, because this actually, let's go look at this. I think we can actually, I think op can do this. Because we shouldn't be mutating op. Yeah, Bob, perfect. This expression, okay. Same here. Whoops, no, we need the paren. Okay, this is pretty exciting. We don't have many. Okay. Back to binary. Oh, we never implemented eval binary. Okay, that's fine. That's fine. Line 38. Okay. Is this context eval binary? Can you go to context? Context calls fun. Oh, which we look it up. Eval binary. Binary op. Okay. And we go to binary. Okay. Binary op. You alright? My dog's coughing behind me. You alright, buddy? Good. Binary op. I think I need to take the space out. Binary op. Binary op. This is the interface. Eval binary. Oh boy. So it's return a value. Takes a context. I think it's this for binary built in. Maybe it's not that. We're trying to do it for our built-in operators. Context. I think maybe this is right. Whoa. This could be right. Let's go back a second. Context eval binary. There's only one type of context, so this is in context.go. But there's another, so this context is an interface, right? But there's a struct, whoops, struct context somewhere. This one. Okay, now let's look for eval binary on this. Okay. All right, so this is the one we actually want to do. If, wait, what? Oh, this takes an operator though. Go back. We're supposed to call context eval binary. Oh, we wrote this. Ah, we're calling fun. fun eval binary. What is fun? Fun is a binary op. Oh. Fun is a value dot binary op. Okay. Wait, what? Why do I find this so confusing? Fun is a value binary op. So we need to go to binary op and find its eval binary. C.binary. What does rc.binary do? This returns a binary op. Okay, it's either a built-in. Okay, we need to go to binary built-in and handle its eval binary. Yes. Okay, now their built-ins are handled built-in. Okay. Binary. We need to go see how these are implemented. Binary ops. Plus, here we go. I mean, yeah. This seems pretty obvious, right? Eval binary plus. Okay, so we match self. There's only one option right now. Plus. Great. So we take a context. I'm not sure that we'll use the context here, right? I think we just take left is a value, right's a value. So we're going to return, well, I guess we have to match the types here. Now we're going to look at the types. Yeah, oh, this is kind of a mess, right? We have to match right, and then we have to match left, and we have to figure out, we have to know all the combinations here. Okay, for now, let's go with this. Let's say if right dot is, well, let's go look at value real quick. Okay, is. Alright, if right is int and left is int, then we can just return a value. Actually, I guess we need to do if int I. This always happens. I always generate the is methods and then don't need them. Is left and int j equals right. They don't nest intuitively. What does this say? I think I just closed the chat. Oh, wait, what did I do? Oh, if let and ooh. I don't think we can say this, right? Can you do that? Okay, what's the problem here? To do. Something is very wrong here. Yeah, okay. Okay. Whoops. Let's give that a shot. 2 plus 2. 4. Okay. Wow, we added two numbers together. Oh my goodness. Okay. Okay. Wow, that's great. We just added two numbers together. Let's do it again. 2 plus 2. Oh my god, it worked. Oh, wow. It feels silly to be so excited about that, but I mean, it's the product of hours of work, right? Add two numbers together. Exclamation point. Beautiful. We did it. Is the prompt... Maybe the prompt is telling us that this is the result. Okay, so that looks like infinite recursion right there. Okay, there are some problems. There are big problems. We only know how to add numbers. 2 plus 2, 3 plus 5, 1 plus 2. I'm just wondering if there's like some combination. I mean, 100, or that's not 100, I know. 10,000 plus 2. Great. Yeah, I mean, of course we don't have shifts or anything to make really big numbers. But great, we added numbers together. I think, yeah, we also don't know how to do floats. It looks like we don't know how to parse floats yet. So let's go take a look at that. Wait, do we know how to do rationals? We also don't know how to do rationals. So let's go to value, line 59. Oh, we don't know how to display them. Well, that's easy enough. That's an easy fix. W I slash J. Okay, that's an easy fix. So we might be able to... Okay, 2/3. Does it reduce? It should reduce them as well. 400. Oh. It didn't reduce them. But that's okay. Can we do like 2/3? Yeah, of course not. Oh, right. Okay. So let's try this again. Let's see what's wrong with floats. Oh. Yeah, okay. 2.0. Okay, so it represents floats as rationals. Which I guess is fine. I guess that's fine. Yep, that's a rational right there. Okay. Alright, well we got rationals. How does Ivy? Can we do that in Ivy? Yeah, it just does it the same way. Okay, wow, we're doing the same thing as Ivy. Okay, we displayed rationals. I guess we can do this. We can go ahead and do the same for complex. Actually, let's see what ivy does. I think it's like 2i3. Ooh. Oh, it's supposed to be a j. Ivy 2j3. Okay. That's how it spits it out, 2. This is just right. W I J. Or I. Yeah, that's a little goofy, but that's right. I J J. None. Hopefully we won't get. Okay, this is great. Handle displaying complex and rational values. Okay, that's great. Well, now we can do anything, huh? Expert. Great. Eval binary. Eval binary. This one. Okay. So we know what to do if there are 2 integers. Well, I kind of just want to stick with integers for now. I guess the other thing to do, cargo run 2 minus 2. Yeah, binary minus is not implemented. So we need to add another one. Minus. Clippy. Non-exhaustive. Alright. So this is very similar, except minus. Oh, is that it? Oh, context. I thought there would be more here. Okay. Self, binary op. Oh, I think we never put it in here. I think it's because of the parse. We go back to binary, built-in. We need to say how to parse it from a string. All right. 2 minus 2, 0. Wow. That's not right. Oh, we don't know how to. Uh-oh. Oh, God. Oh, I have the left and the right backwards. Hold on. It actually matters in this case. Left, right. This is actually backwards. Okay. Okay. 5 minus 4. 4 minus 5. 999 minus 1,000. Minus 1. Okay. Woo! Okay. So we know how to add and subtract. Let's go see what else does Go have. Or, yeah, what does Ivy have? So, of course, we have to handle all of this, the different combinations. But let's see what we've got here. Binary ops. We've got J. Oh, I bet. Okay, yeah. So we can't even type one of these. 2J3. Oh, we can. What does J do? Yeah. Okay, so it looks like so we can parse a complex number, but we can't okay, so apparently J is supposed to be that. Okay, so let's just go back over here. Great. We'll just, I guess we'll call it new complex. It gets parsed as J. I don't really care about that one too much. But we've got, alright, we've got new complex, we got plus, we got minus. Let's do times. Times. This is star. Probably should we call it, yeah, plus minus times. I guess we should call it mol, right? Because we're going to call it divide div. Rational division. Div. Integer division. Oh, you have to say idiv. It'd be kind of cool to use like // integer mod. I guess we'll throw in mod exp. Okay, so we got new complex plus minus mul. We got div. We got mod. And then we got exponentials. Log. I think we'll skip log. What is this? Oh, I think this is... Oh, okay, these are bitwise operators. Skip these for now. Shift equals. We are going to need equals. Yeah, we'll need equal, not equal, less than, less... Wow. And, or. XOR, nor. Question mark is like a random thing, I think. Decode. Encode. In iota. Oh, boy. All right, we'll have to we'll skip those for now. So let's just do math at the moment. Okay. You know, I think this might be exactly what Rob Pike was talking about in his talk about how the type combinations are exploding, and this might be why we were supposed to do it the other way, or do it a different way at least. So we'll see. We'll see. There's probably a better way to do this. So I guess we'll do the J. J. Yeah, it just gives us a new complex. Yeah, again, we're assuming that these are integers, I think. Value, complex. Oh, it actually takes two values. Oh, okay, we can get rid of this then. It just takes the two values. Left, right. Easy enough. Multiplication. We'll need this again. Okay. Mul is just times. Div, I think, is a little bit tricky, potentially. Because, well, no, okay, it's not tricky because we just use whatever Rust does. Yep, don't care, because we know they're both integers, so we just use Rust's integer divide. Here we use Rust's integer modulus. And we might be able to write some macros to help us out with this, but we'll see. Now this one, we have to use POW. This might be the wrong type. expected U32, found I32. Let's do try into .unwrap. To do don't unwrap here. What do they do? I div, I mod, div, mod, star, star. Okay. Oh, I guess we're supposed to do this actually. Switch v.sign. Okay. Let's see. Let's see ga.sign. What does this do? Apparently nothing. Returns a number representing sign of self. Okay. So, if, well, let's do this. Let s equal this. If s is 0, then I can return value int 1. Else if s is -1, then we will error, panic. Actually, we'll just return. Is there any other thing we can do for POW? Guess not. Okay, we've got more operators. Cargo run. Let's test them all out. So we can make a new complex number. Okay, we're gonna have to fix that at some point. So we got 2 times 3. How about 2 over 3? Great. 2 mod 3. 2 star star 3. It says this one is not yet implemented. At parse. 412 variable. That doesn't seem right. Self exp. Okay. Binary built in. Okay. Parse built-in error needs to be debugged. Yeah, okay, it's supposed to be an exponent. Okay, why is it's trying to parse it as a variable? Okay. I don't know why it thinks it's a variable. Number or vector. Operand. Expression. Statement list. I mean, I suspect that it's something with... But it gets parsed. Like, the operator gets parsed. Okay, so there's something wrong with our parser. I'm not too upset about it for now. Okay. Actually, maybe we should just do this. To do something wrong with exponent parsing. Okay. You know, that way people, at least we get like a nice error message here. Yeah. What? Oh no, it still hits the other one. Alright, well, leave it out. Alright, so exponents don't work. Does everything else work? I think everything works except for exponents. Oh, and the complex thing doesn't work. 2j for some reason doesn't work. Yeah. Maybe we should debug that one. J3. Yeah, okay. That works fine, because that parses it itself. Okay, so something's wrong with parsing the new complex operator as well. Yep. Okay. Great. We'll say successfully implement minus star slash and this for ints, fail on others. Then we'll just clarify what the others are. So new complex and exp are not working. The former fails, overflows the stack, and the latter dies in the parser. Okay. Well, let's see, 2.5 hours. That might be enough for me today. We got something working. Actually, let me take one last look over here. Let's close this. I want to see how it handles the types. Big int type. I'm just wondering how it gets this. Big int type. Because we just need to look at the types of them, right? Yeah, I guess what we're going to do is we're basically going to come up with a matrix for how the different value types transform into each other. So, for example, let's see, let's pull up our value over here. So, if we have a float and an int, we will probably just convert the int to a float, and you get back a float. If we have a, I'm not actually sure how we construct a float at this point. We might just get rid of, I might get rid of all of this. I really only care about floats and ints. But anyway, so basically we just have like a table of what do we do with each thing. I guess it's not much different than what we're doing here. I guess, for example, if we have else if let value rational equals right, well then, oh man, and then we have to do it for like each way, right? Yeah, ij is right. Then we need to create a rational. Oh, we should actually store these. Ugh. Yeah, we should definitely store them as rationals, right? Like this should be a num rational 32. Because then addition will be taken care of for us. So definitely need to fix that. I think Rust has complex numbers too. Just built in, maybe? Or we can use num complex. So we can use the num crate for all of this. And I guess that won't be too painful. And probably we can keep this internal rational handling the way it is. But we can make it like a display option to display rationals as floats. So for example, if I'm going to do data analysis in algae, I don't want all of my floats converted into just wacky rationals. So, yeah, there's stuff to play with. As anything, the translation is like the first step. And then once we have a good idea of what's going on and the basics working, we can start doing things that are more fun. So, I guess I'm just deciding now if I'm going to stop or not. I don't have a really clear idea where to go next. I guess we could try porting the tests and like reading from. Yeah, let's do that real quick. ib.go run file. Let's see actually how hard this is to do. Let's go to main. So we need to build our scanner not on standard in, based on something. Star file. Oh, I guess if we'll just check if it always selects the little chat box. All right, let args equal standard env args. Okay. First, next. I think this is generic, right? Okay. Let's say if let sum in file is args.next, we're gonna let our scanner. Whoops. Else. Of course, we have to do this first. Scanner. Wait, what's it said about? Scanner. There we go. That's what we wanted it to be upset about. Okay. So it needs to be something that's read, so we're going to try to open the file. File. Open. In file.expect. Be able to open file. And we'll make a scanner on that. Scanner new context. I don't think this name is ever used, right? It's gonna say the types are different, of course. Can I just inline this? Does that work? If and else. Oh. Struct file. Does it have to be din? Whoops. Great, now we're gonna have more trouble. Box, din, read. R is never used. Great. Parser tick A R with parser tick A. Okay, get rid of that. Get rid of that. Standard IO, read, plus debug. Okay, well, we're not going to be able to debug it. So now our scanner can't be debugged, which is fine. Type annotation is needed. This is no longer like that. Same thing here. And hopefully that's it. Scanner new. Box new. Box new. Okay, makes sense. Great. That's, I guess that's halfway there. All right, let's try that. VI demo. I guess we'll call it that anyway. All right, cargo run. Whoa. What? Wow. What? String from UTF-8. Okay, wow, I was not expecting that. Self.buff.clone. Wow, that is nightmarish. Okay, yeah, I think time for debug is still right. Debug buff. What's buff? Self.buff. Oops. I have to say, I certainly did not expect this to be a total disaster. Yeah. Maybe we should debug C, huh? Rust file. Okay. Read. So it's supposed to read bytes. Transforms its read instance to an iterator over its bytes. Is this just like looping forever? Maybe there's more to this. Yeah, where's run file? This should be okay, I thought. Yeah, open the file. Oh, we need a... No, we don't need a buffered reader. Okay. Yeah, I just don't know. Print line, called load line. I mean, how many times should this be called? Okay, it just gets called once. Okay. Self.r.bytes. Self is sized. I don't know what's going on. There should only be 3 characters. Debug self.r. Probably can't clone it, right? Self.r.chars. Okay, is there like read all? Let's just read all. Read to end. Okay, let's just try self.r.read to end. Oh, read to string. Okay. Stream did not contain valid UTF-8. What? Let's see if I mess this up, just in general. Oh. Yeah. Yeah. Okay. That's weird. Isn't it? Okay. Yeah. Alright, let's try this args thing again. Then I think run file I guess we'll just do it more like how they do it. Just make sure some stuff still works. Okay. So. Let's just see if we can do this. All right, let's see if this works. Wait a minute. Is it always coming in here? Is that what's happening? Yes. Oh my goodness. Oh, dummy, 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 dummy. It's not next. It's nth one. Goodness. Okay. Yes. Okay, it worked. It's still printing the prompt for some reason. And still at the wrong time, but at least it works. Okay. Demo. 2 plus 2. 2 times... Okay, maybe we should do something more interesting. 2 plus 2. 2 times 3. 2... let's do, 12 over 3 over 6. Let's say, look, we can skip comments. We can do addition, we can do multiplication, we can do subtraction. Let's do a -1. We can do multiplication, division. That should be 2. What else can we do? We cannot do exponentials or create complex numbers. Oh, there's so many blank lines down there. Okay, we can do it. We can run it. Okay. Let's actually rename this. What's our file extension going to be? Maybe alg. Rename to demo.alg. And then we can copy the demo clone ivy demo. Okay, so we'll see how far we get here. Okay, this is our new test. We do math, we get a 4, we get 23, whoops, make file, run, cargo run, ivy. I think we can leave this out actually. Here we go. Okay. Let's see. So we've got... Whoops. I just want to like reformat this so it's not... Alright. So we make it through this. Let's run it again. Why are there all of those new lines? Well, obviously they're from the comments. All right. 2 plus 2, 23, 68. That's probably right. 23 minus 45 is this. Okay, and then here we go. Okay, so we are back to our, all right, I think I'm going to call it, that's good. We've got, this is a real test. Let's go back to our README real quick. README, let's do, I like to call this a line survey. To-dos. Alright, let's get these in here. So, print the prompt when prompting, not echoing, not printing results. So that's one to do. The next to do is don't print the prompt for comments. Okay, to do handle exponentials. To do handle the rest of demo.id. Okay, so this is our target, is to make it through this file successfully. Yep, the classic poop emoji, thank you. Great. Very exciting. All right. I don't know about that. Let's see. Okay. Allow reading input files. Reading commands from file. Something like that. Okay. Add run recipe. Add sections in README. And new to-dos section. Let's go back to the README for a second. Of what we support, demo.alg, and IV demo as test. Okay. So I think for now, we'll just try to handle demo.iv, and we'll measure that by make it through without crashing. And then later we'll turn that into a real test like they do in Ivy. Demo test.go. It looks like they, yep, you just run, you set the stand out, stand error to a bytes buffer. We can just set ours to a string. And we'll be able to collect the output of running that file and see if it looks like this. Yeah, great. So this is what it's supposed to look like. We'll see how it goes. Great, but again, I think that's going to be it for me today. Thank you to everyone who stopped by. Matthew especially, thank you for all of your help. And for the questions about my research. Hopefully I'll make an actual video on that at some point. But anyway, with all that said, I will see you guys next time. Thank you, sounds good. See you then.